You hear some noise in the street and rush up to the window to check what caused it. You look up at the sky and just stand there, speechless. The moon is giant! It looks much larger than usual, and it's both beautiful and scary. So what would your life be like if the moon moved twice as close to Earth as it is now? Unfortunately, it would be quite a catastrophic scenario. You see, the moon has a pretty strong gravitational pull on Earth's oceans. It produces 2 high tides and 2 low tides per day. But with the moon so close to us, the tides would get 8 times higher. Some regions would be completely covered with water during the day. The water would only retreat at night. Many islands and highly populated coastline territories would become uninhabited because of this. Many other regions would experience frequent devastating floods. But if you think it would be the only consequence, let me tell you this. The moon also has a tidal effect on dry land. That's why if our planet's natural satellite was to suddenly relocate, its gravitational pull would increase, making waves of energy reverberate throughout the planet. This would affect Earth's crust, triggering earthquakes and starting volcanic eruptions. Now let's leave Earth and the giant moon for a while and have a look at Jupiter's moon, Io, which is the most volcanically active world in our solar system. This volcanism comes from the push and pull from Jupiter's gravity. 2 other moons of the gas giant also have an effect on poor Io. That's why Io's surface is littered with hundreds of volcanoes. Most of them are spewing sulfurous plumes high above the surface of the moon. Our planet might face the same fate should the moon move so close to it. And that's not all. Earth's spin would start to slow down over time. Look, the moon's gravity pulls the oceans, and the resulting friction between the water and the ocean floor slows Earth's spin. Yes, Earth is slowing down even now as you're watching this video, but this process is almost imperceptible, around 1/1000th of a second per century. If the moon was twice as close to us, the rotation of our planet would slow much more, making days and nights longer. If people managed to survive unexpected earthquakes, high tides, and volcanic eruptions and got used to longer days and nights, they would get an award. Solar eclipses. These spectacular events that occur when the moon passes between the sun and Earth would happen much more frequently. Since the moon would cover a much larger area in the sky, it would pass in front of the sun more often. People on Earth would be able to see the sun's outer atmosphere, called the corona. It would shine beautifully around the silhouette of the moon. Such solar eclipses would also last much longer. But what if the moon didn't shorten the distance overnight? What if it was a much slower and much more gradual process? Then our planet's crust would shift more slowly. Tides wouldn't change so dramatically either. This would let living creatures on the planet get used to the new conditions and adjust in time. Longer days and nights would likely change the climate, and animals would have to evolve to adapt to it. Their eyes would have to change to be able to deal with brighter moonlight at night. Prey would have to learn to hide better, but predators, on the other hand, would have more advantages when hunting. But what catastrophe would have to happen to make the moon move so close to Earth? Well, it could be some massive object, like a giant asteroid passing very close to the Earth-Moon system. If the moon was in the way of this space traveler, it could take energy from Earth's satellite, which would cause the moon to spiral towards our planet.
Have you ever seen the other side of the moon? Ah, I caught you. Of course not. But maybe you've seen it in photos. In that case, have you ever wondered why the 2 sides look so different? Well, let me tell you. We can't see the other side of the moon. People believe this is because the moon doesn't rotate around its axis. But this is not true. The moon does rotate. It just does it at the same rate as its orbital motion. This is a particular case of tidal locking called synchronous rotation. The first time we ever saw a far side was only in 1959, all thanks to the Soviet Luna missions and later the US Apollo program. Now, when Luna 3 and other spacecraft transmitted the first far-side images, they revealed a far more cratered hemisphere that looked more like Mercury or Jupiter's moon Callisto. It looked completely different from what we were used to, and that's when we learned how meh the other side is. No, seriously, just look at it. The near side can boast its thinner and smoother crust. These beautiful dark splotches are called lunar mare, the last remnants of ancient lava flows. And when I say ancient, I mean it. They're more than 3 billion years old. Meanwhile, the far side crust is thicker and crater-pocked. The lava flows had almost no effect on these impact craters. It's also devoid of any large-scale mare. Low-key looks like dried white cheese. To be honest, don't you agree that the nearby side is much more beautiful? Write your thoughts in the comments. So, only 50 years ago, we learned something about the apparent differences. But then the scientists discovered something weird. Both sides are different, even in the geochemical composition. And not only in this, our side was thinner than the far side by several miles. But where did such significant differences come from on an ordinary floating stone ball? For scientists, this was a mystery. They started coming up with a lot of theories. The melted moon theory was the main one for a while. It said that it was the Earth's fault that our moon looks like this. This happened several billion years ago. The moon was born because of a collision. One day, an object about the size of Mars crashed into the Earth. At that moment, a piece broke off from it, which later became the moon. However, this piece was somewhere 15 times closer to Earth than it is now. Some scientists created pictures of the so-called early moon. Unlike our cute little white ball, the early moon was a strange-looking, boiling scarlet ball. That piece didn't leave us after the separation. It became tidally locked very soon after. The Earth after the collision was still an incandescent nightmare, full of fire and lava. It was boiling at a temperature of 4,500 degrees Fahrenheit. And since the moon has always been turned toward us with one side, this side has melted down a little. This would explain why the moon's surface, the so-called mantle, is thinner on the near side than on the far side. During the boiling of the Earth, certain elements evaporated from it. They then settled on the moon. This would explain the difference in geochemical composition between the two sides. But there was a plot hole in this theory. If that's what happened, then where did rare foreign chemical elements come from, such as unusual isotopes of phosphorus, potassium, or tungsten? The nearby site is full of them, and they couldn't have come from the Earth. There were also other theories. Another one said that initially we had two teeny-tiny moons. Later they merged into a big one, hence the difference in their composition. But this theory sounds a bit crazy, and it has a plot hole too. For example, the transition between the two sides is way too soft. If our moon was actually two tiny moons, this transition would be more abrupt. So scientists were kind of at a loss on this one. But recently, they finally figured out what really happened to the moon, all thanks to NASA's Grail orbiters. They spent over a year whizzing around the moon, mapping it out, and studying its composition. Using this data, scientists have created around 360 computer simulations. They contain different impacting objects of many sizes, traveling at different speeds. Scientists were comparing the results with our current moon. They tried to determine which result was the closest to what we have today. And so, they finally solved this 50-year-old mystery. The answer lies in a collision with a dwarf planet. This collision occurred 4.3 billion years ago. This huge object was slightly larger than Ceres. For those who don't know, Ceres is one of the dwarf planets of our solar system. Its diameter is 580 miles. You could say that one France or one Germany would fit into it. So, this giant object crashed into the moon, somewhere near the South Pole. This collision was so strong that it changed the image of the moon forever. It left a trail of 3,500 miles behind. It would take you 14 hours by plane to fly that distance. This crater covered the entire near side of the moon. It caused damage to the moon's mantle. It also created a so-called South Pole Aitken Base, or SPA Basin. This is an impact crater and has a diameter of 1,600 miles, which is like adding one UK plus one Germany. It's important, though. The formation of this basin was a defining event in the history of the Moon, and it's the second largest impact crater in the Solar System. The collision also caused a powerful hot wave to spread across the Moon. This wave scattered over the remnants of those rare warm minerals scientists found on the nearby side. That's how our beautiful side became home to something called Procellarum creep terrain, or PKT for short. This is basically a compositional anomaly, a concentration of potassium, phosphorus, and other rare elements like thorium. You can say that those minerals are a gift to us from deep space. Anyway, there were many, and I mean many, collisions in the Moon's history. All of them only deepened this already large crater. That's why the mantle on the near side was getting thinner and thinner with the years. Also, our gifted minerals gave off a lot of heat, so the mantle has melted a little bit more and more. Oops, this accidentally caused the Moon's volcanoes to wake up. Volcanic activity has increased on the near side. Intense lava flows filled the old empty craters. Ta-da! And this is how the beautiful lunar mare was born. That's about how it all happened. All this information was found thanks to the researchers from Brown, Purdue, Stanford Universities, and NASA's JPL. The research was published by the Journal of Geophysical Research, Planets, so you can read about it in more detail if you're interested. There are still many things we need to learn about the Moon. The highest priority is the return mission from the South Pole, the Aitken Basin. Samples brought from there will be used to determine the age of the Moon, its history, and the nature of the crust and mantle more accurately. Another critical target is the Moscoviense. This is the name of a large lava plain on the far side of the Moon. Studying it will help us better understand the difference between the two sides, as well as tell us how the other side was formed. All this knowledge is significant for understanding the history of the Moon, but it's also handy for space exploration in general. Scientists use the Moon as a reference point to determine the age of other planets and entire worlds in space. The Moon helps us determine the chronology of the life of the whole solar system. So, stay tuned for new exciting research and discoveries. You're strapped in your seat in the vast open space with Earth behind you getting smaller and smaller. All around you are toggles and controls to keep the spacecraft intact. You and two other crew members are working hard at those controls. Out the window, you see some meteorites flying by and stars and planets out in the distance. You're about to be one of the first people to land on the Moon after years of research and testing. You have to consider all the steps perfectly. Otherwise, you could face many complications, like crashing into a flying asteroid, or even being left in the vacuum of space without any way of getting on track. Research shows that around 1/3 of all moon landings faced many problems. Launching towards the Moon requires a special rocket traveling at more than 25,000 miles per hour. And once in lunar orbit, the spacecraft can detach itself from the rocket and navigate its way to the surface of the Moon and land. Sounds simple, right? Well, figuring out the math to land was the reason landing a human on the Moon used to seem like a ridiculous idea. But scientists were able to pull it off by studying and observing the flight of helicopters. Unlike an airplane that needs velocity to take off, the large propellers on a helicopter give it a good push to fly around. It basically has to twirl with enough force to lift its own weight from the ground. With that in mind, we need to consider the gravitational force pulling everything down. On Earth, the force of gravity is 32 feet per second squared. On the Moon, it's only 5 feet per second squared. So we got landing on Earth figured out for the most part, but what about landing on a surface that barely assists you in that? There had to be 3 steps, doing all the research and math needed for calculating the proper conditions, using a test vehicle to practice in, and using a flight simulator to imitate the conditions of the Moon's atmosphere. Choppers weren't really good references for landing, since gravity is doing most of the work. and the spacecraft looks nothing like a helicopter. They needed to simulate a spaceship of only 5/6 the weight of it. Since the gravitational pull on the moon is weaker than on Earth, navigating it under these conditions is vital for when the real thing comes. The scientists of NASA decided to get a crane hanger to lift the spacecraft with cables while simulating the flight and landing. Kind of like stunt actors in a movie with cables attached to them for action fight scenes. But it still wasn't enough to determine if you could actually land properly on the moon without the safety cables to help you. They needed proper freedom. So it was back to the drawing board. They were about to throw in the towel until they came up with a brilliant idea to simulate the landing conditions on the moon by installing a sort of detachable jet fan into the bottom of the spacecraft to keep consistent thrust upwards. By doing this, they were able to create a scenario where the craft would be 5/6 of its weight on Earth and without the safety cables to hold it. But after many trials and errors, the only way to see if landing on the moon was possible was by actually doing it. So, being so far away from Earth, you and your team see the moon out your window. It's a lot bigger than it looks from Earth. Its surface fills up the entire window. But landing won't be a piece of cake. The spaceship has to orbit around the moon to determine the best time to land. And don't worry, that's why you have a team for that. It can take more than 24 hours to know when and where the perfect place to land is after performing various tests and measurements. And once you get the best calculations, the actual spaceship detaches from the orbiting one and makes its way downwards. This is where the helicopter physics come into play. A helicopter needs to tilt at least 5 degrees to move forward after ascending from the ground. Same for going backwards. But that's because we have gravity to assist it. Up above the moon, soaring through the vacuum of space, the ship would need to tilt at least 30 to 40 degrees to move forward. As soon as the ship reached a nice spot for landing, it would go back to 90 degrees and slowly land on the surface. As you get closer, you can see the moon's surface just a few feet away. This is the tricky part, but it's a success. The team back on Earth couldn't be happier. The crew members are also thrilled about what you've achieved. You put on your spacesuit and gear and climb down the ladder. You leave your first footprint on the moon and look out at the distance ahead of you. The Earth is just a little blue dot far away. You're able to bounce around in the near-zero gravity. Now, that's what I call moonwalking. After spending much time on the moon, it's time to head back. Neil Armstrong, the first man to step on the moon, spent only about 2.5 hours on its surface before returning. But, oh no, you forgot the keys inside the ship and now you're stranded. Nah, just kidding. Although it would have made a good plot twist. You get back and launch the spacecraft back into orbit to reunite with the other ship above you. And once you've reattached, you exit the moon's orbit and head back to Earth. By sending humans to the moon consistently, the next big step can be achieved by landing on Mars. The famous exploration rover Curiosity traveled around the surface of Mars and gathered information needed for humans to land there. And NASA is aiming to have the first humans up there after 2030. The journey will be hundreds of times harder than the one towards the moon, but many scientific questions will be answered once it happens. Humans may be able to gather some of the natural resources there and even build outposts and colonies. There are endless possibilities as well as challenges. The journey from the Earth to the Moon is around 250,000 miles. Mars is around 35 million miles away. There could be a possibility of a new human outpost station on Mars, building a new society of scientists and engineers to make the most out of the conditions. It would be completely self-sufficient, providing proper ways for farming and agriculture. And by having humans on Mars for so long, scientists can properly understand the planet. But to understand how the human body responds to deep space environment, we'd have to have a lot of practice before getting that ticket to Mars. The closest experience of having a colony in the middle of nowhere is the Amundsen Scott Station on the South Pole. It's designed to withstand all the harsh conditions of the freezing dry cold. Being at the bottom of the world can be pretty stressful without proper practice. The journey may not be as far as Mars or the Moon, but being on the South Pole is like arriving on a whole new planet. The station itself is equipped to provide the proper conditions everyone needs to be comfortable. Besides the strong heating system, the station has a recreational room for sports and music, a library, a lounge, and even a greenhouse to grow all the right veggies and fruits. In fact, the greenhouse is the only way you'd get to feel like you're in a rainforest. And even before applying there, you'd have to get screened to see if you can handle the isolation for months. Not that you'd be completely alone, but still away from civilization. Antarctica's whole population consists of scientists and engineers, and you need to be examined by a doctor to determine if you're physically fit to stay there. The station is built there for scientists to study space and things related to geology. Being in the biggest desert in the world can take its toll on you. When leaving the station, you have to wear at least 3 layers of gloves and extremely thick sweaters and jackets to withstand the cold. They even compared stepping on the South Pole to walking on the Moon.